Imagine a world where the hands that feed us are no longer just human. Picture vast fields at dawn, where sleek, autonomous machines work silently alongside seasoned farmers. Is this a dystopian future where people are obsolete, or the dawn of a revolutionary partnership? Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. A silent revolution is happening in our fields. For millennia, agriculture was defined by the rhythm of human labor, a cycle of sowing and reaping tied to the seasons and the strength of our backs. The Industrial Revolution brought tractors and mechanization, transforming family plots into sprawling, industrialized operations. But today, we stand on the brink of an even greater transformation, the digital and robotic age of farming. This shift isn't just about bigger machines, it's about smarter ones. As we witness this incredible evolution, a central question emerges, hooking us both intellectually and emotionally. Are robots here to replace farmers, or are they poised to become their most indispensable new partners? The answer is far more complex and fascinating than you might think. The journey of automation in farming has been a long and accelerating one. What began as simple mechanical tools has now blossomed into a sophisticated ecosystem of AI-powered systems. These are not your grandfather's plows. We are talking about machines capable of sensing their environment, learning from vast datasets, and acting with a degree of autonomy that was once the stuff of science fiction. The rise of these agricultural robots is a global phenomenon, reshaping farming practices from the heartland of America to the high-tech greenhouses of the Netherlands and the terraced fields of Japan. Let's look at the specific technologies driving this change. AI-powered vision. Drones soar above the crops, their cameras acting as the farmer's eyes in the sky. They monitor plant health, detect early signs of disease or pest infestation, and map out nutrient deficiencies with pinpoint accuracy, allowing for targeted intervention before a problem spreads. On the ground, robotic weeders navigate between crop rows with surgical precision, identifying and removing unwanted plants without the need for broad-spectrum herbicides. This not only saves costs but also significantly reduces the chemical load on the environment. Then there are the heavy lifters, self-driving tractors, guided by GPS and a suite of advanced sensors. These autonomous giants can plow, plant, and till fields around the clock, operating tirelessly and with a level of consistency that human drivers can't always match. And perhaps most delicately, we have the rise of robotic harvesters. In orchards and strawberry fields, these machines use advanced vision systems and gentle robotic arms to identify and pick only the perfectly ripe fruit, a task that has long been considered too complex and nuanced for automation. Real-world case studies provide tangible proof of this progress. In California's Central Valley, robotic systems are helping to alleviate labor shortages during peak harvest season. In Japan, where the farming population is rapidly aging, small-scale robots are being developed to assist elderly farmers with physically demanding tasks. Meanwhile, the Netherlands has become a global leader in automated greenhouse farming, using robots to create highly controlled, hyper-efficient growing environments. These examples are not just futuristic concepts. They are credible, functioning systems that are already delivering results on the ground today. While the gleaming chrome and whirry gears of these machines are impressive, it's crucial to shift our focus from the technology itself to the people behind it. The narrative that robots will make human farmers obsolete is a simplistic and misleading one. Instead, what we're witnessing is a profound evolution of the farmer's role. They are transitioning from being primary manual laborers into becoming highly skilled managers of complex technological systems. The farmers of today and tomorrow are no longer just growers. They are becoming robot operators, data analysts, and even programmers. Their deep, intuitive knowledge of the land is now being augmented, not replaced, by the precision of data. This technological wave is also creating a host of new job opportunities within the agri-tech ecosystem, roles that didn't exist a decade ago. Agricultural robotics engineers are in high demand to design, build, and maintain these sophisticated machines. Certified drone pilots are needed to survey vast acreages and manage the flow of aerial data. Agri-tech specialists and data scientists have become essential personnel, tasked with interpreting the terabytes of information collected from sensors, drones, and soil monitors to optimize farm operations and improve decision-making. The most powerful stories, however, come from the farmers themselves. We see multi-generational farmers, initially skeptical, now embracing digital tools to manage their land more effectively. Young agronomists are returning to their family farms, armed not just with the knowledge of soil science, but also with skills in coding and data analytics. These personal accounts humanize the narrative, providing emotional resonance and reinforcing the idea that innovation can be an inclusive force. They show us that adapting to digital systems isn't about abandoning tradition, but about enriching it with new capabilities, ensuring that the legacy of farming can continue for generations to come. The human element, with its experience and intuition, remains the essential core of this new agricultural paradigm. One of the most compelling arguments for integrating robots into agriculture lies in the immense benefits for both efficiency and sustainability. This technological shift isn't just about doing things faster, it's about doing them smarter and with a much lighter footprint on our planet. Robots enable a level of precision that was previously unimaginable, leading to a dramatic improvement in resource efficiency. By analyzing real-time data from soil sensors and aerial imagery, automated systems can optimize the use of critical resources like water, fertilizer, and energy. Instead of irrigating an entire field uniformly, smart systems deliver water only where and when it's needed. Similarly, fertilizers and pesticides can be applied with surgical accuracy, targeting specific plants or problem areas rather than blanketing the entire crop. The predictive power of artificial intelligence is another game changer. By analyzing historical data, weather patterns, and real-time sensor inputs, AI algorithms can predict crop yields with remarkable accuracy, forecast potential disease outbreaks, and determine the optimal time for harvest. This predictive capability is instrumental in reducing waste and minimizing post-harvest losses, a major challenge in global food supply chains. The positive environmental impact of this precision agriculture is profound. Reduced chemical usage leads to less runoff, polluting our waterways and healthier soil ecosystems. Optimized machinery operations and autonomous electric tractors contribute to lower carbon emissions. Overall, robotic agriculture promotes better soil health, conserves water, and helps build a more resilient and sustainable food system. Using clear data and visual comparisons showing the resource consumption of a manually farmed plot versus an automated one, for instance, vividly emphasizes these tangible results. This appeals not only to eco-conscious viewers, but also to farmers and business leaders who recognize that sustainable practices are integral to long-term economic viability. At its core, this agricultural revolution is not about a battle between humans and machines, but about the creation of a powerful human-robot partnership. The emotional and philosophical heart of this story lies in collaboration, not replacement. The most advanced farms of today offer a glimpse into this collaborative future, where the unique strengths of both humans and robots are leveraged in harmony. Imagine a scenario where robotic harvesters methodically move through an orchard, picking fruit with tireless efficiency. Working alongside them are human quality inspectors, whose trained eyes and hands can spot subtle blemishes or assess firmness in a way that machines still struggle to replicate. The robot handles the repetitive, physically strenuous labor, while the human provides the final layer of quality control and nuanced judgment. This is a perfect illustration of teamwork, where technology amplifies human ability. This partnership works because there are fundamental aspects of intelligence and decision-making that remain uniquely human. Machines excel at processing vast amounts of data and executing predefined tasks with precision. However, they lack the emotional intelligence, creativity, and intuitive understanding that are often crucial in farming. A farmer can walk a field and, based on years of experience, feel that something is off. A subtle change in the color of the leaves, the smell of the soil, or the behavior of insects. This kind of holistic, intuitive knowledge is incredibly difficult to program into an algorithm. Empathy, the ability to care for the land and the life it supports, and the creativity needed to solve unexpected problems are qualities that cannot be automated. Technology, therefore, becomes a powerful tool in the hands of a skilled human, not a replacement for them. The ultimate conclusion is a reassuring one. Technology is here to amplify our capabilities, free us from the most arduous tasks, and allow us to focus on the strategic, creative, and nurturing aspects of farming that we do best. The future of farming remains a deeply human-centered endeavor. Of course, no major technological shift comes without its challenges and controversies. To present a balanced and credible story, we must also address the darker, more complex side of automation in agriculture. The most immediate and widespread fear is the potential for significant job loss. For generations, farming has provided livelihoods for millions of agricultural workers around the world, many of whom perform the manual labor that is now being targeted for automation. The prospect of displacement for these workers is a serious concern that cannot be ignored. This leads to another critical issue: economic inequality. The high upfront cost of advanced robotic systems and AI platforms means that large-scale, well-capitalized corporate farms are often the first and most able to adopt them. Smaller family farms, which are the backbone of many rural communities, may struggle to afford this technology, putting them at a competitive disadvantage and potentially accelerating the consolidation of farmland into the hands of a few large players. This growing technological divide could exacerbate existing economic disparities within the agricultural sector. These challenges raise profound ethical and policy questions that society must grapple with. How do we ensure a just and fair transition for workers whose jobs are displaced by automation? What responsibility do technology companies and governments have to provide retraining programs and create new pathways to employment? How do we structure policies to ensure that the benefits of agritech are accessible to farms of all sizes, not just the largest operations? Ignoring these questions would be irresponsible. Instead, we must explore potential solutions. These could include government subsidies and low-interest loans to help smaller farms invest in technology, the creation of robust retraining programs focused on the new skills needed in agriculture, and the development of collaborative frameworks where tech companies work directly with farming communities to ensure that new tools meet their real-world needs. Acknowledging these complexities makes our narrative not just promotional, but thoughtful, credible, and truly engaged with the real-world implications of this revolution. As we look to the horizon, what does the future of farming truly hold? The vision is one of a sophisticated, hybrid agricultural ecosystem where humans and machines share responsibilities in a seamless and harmonious partnership. This is not a future devoid of people, but one where human roles are elevated and redefined. Drawing on the predictions of leading experts in agriculture and technology, we can begin to paint a picture of what farming might look like in the decades to come. Around 2040 or 2050, we envision the rise of fully autonomous farms, where fleets of interconnected robots manage everything from planting and irrigation to pest control and harvesting, all overseen by a human manager monitoring operations from a central command center. We see the proliferation of vertical farms in urban centers, powered by AI that precisely controls light, water, and nutrients to grow fresh produce year-round, drastically shortening supply chains and increasing food security for city dwellers. Beyond individual farms, we can anticipate the development of vast, smart data ecosystems. These networks will integrate on-farm data with real-time climate predictions, global market trends, and supply chain logistics, creating a highly responsive and efficient food system that can adapt to challenges like climate change and shifting consumer demand. This interconnectedness will allow for unprecedented levels of optimization, from the seed planted in the ground to the food that arrives on our plates. This visionary future is both exciting and inspiring. But as we close, it is essential to return to the human core of this story. The ultimate message is one of hope and empowerment. The farms of the future won't be just robotic, they won't be cold, sterile, and impersonal. Instead, they will be dynamic systems driven by the timeless qualities of human curiosity, the relentless pursuit of innovation, and our innate sense of stewardship and care for the planet. Technology is the tool, but humanity remains the guiding hand, ensuring that the future of agriculture is not only more productive and efficient, but also more sustainable, equitable, and deeply connected to the earth we all depend on.